Okay. So these problems, there are 3 of them right here. These are all degrees, so these should be easier ones for us. Okay, first thing I think about is the trig function. Sine, what is that in terms of x and y? Y, very good. 240. If you know your unit circle, if you have it memorized, you can just go right to 240 and figure out what your y value there is. Let's say you don't. I made you memorize quadrant 1 because I think that's all you have to know. 240, is that related to 30 degrees, 45 degrees, or 60 degrees? 60, very good. And if you didn't know that, I do know that 180 plus blank equals 240, and that number is 60. And what quadrant is 240 going to be in? Is it between 0 and 90, 90 and 180? It's in quadrant 3 because it's between 180 and 270. And you guys all know the first quadrant, so you know that 60 is 1/2 root 3 over 2. It's in quadrant 3, so they're both negative, and I want the y value, so my answer right here is negative root 3 over 2. That's it. You don't have to write any of that. You can just write the answer. I'm just telling you all the things I'm thinking. Okay? Similarly, cosine. I'm going to look at the trig function first. What's cosine in terms of x and y? X. Very good. Then I decide 150. Is that a 30-degree angle, a 45-degree angle, or a 60-degree angle? 30. This time I'm in quadrant 2 because I'm not quite 180. How much less than 180 am I? 30. Okay. That's how I got to 30. Okay. My 30-degree angle or point I know is root 3 over 2, comma 1/2. I'm in quad 2, which means my y is negative, and I want my x. Oh, my answer is a negative root 3 over 2 again. That's okay. You can have that as many times as you need. Questions on the first 2? All right, tangent. What's that in terms of x and y? Ooh, other way. Y over x. And 45 degrees, is that a 30-degree, 45, or 60-degree? 45, because it already told me. It's in quadrant 1, so everything's positive, and that's the root 2 over 2, root 2 over 2. It's going to be 1, and hopefully we've done this enough times that you know a number divided by itself is just going to be 1. Now, let's say you forget and you panic. You can write out root 2 over 2 divided by root 2 over 2, and then cross multiply and all that fun stuff. You'll get 1. But I'm arguing you don't even need to show that because we've done it enough times. Okay, everybody good with this first 3? Okay, the next 3 deal with my reciprocal function. So you got to remember which ones go together. That's good. All right, so cotangent of 5 pi over 3. Okay, let's start with my trig function. Cotangent is what in terms of x and y? Oh, cotangent goes with tangent. So it's the reciprocal of tangent. It's x over y. Okay, now we're in radians. These are all radians. My pi over 3s, are those 30s, 45s, or 60s? 60s. I know my 60-degree angle or my 60-degree angle point is 1/2 comma root 3 over 2. Do you know what quadrant we're in for 5 pi over 3? 4. We know 6 pi over 3 is 2, so we're almost 360, we're almost 2 pi, but we're a little less. So we're in Q4, which means my x is positive and my y is negative. I'm going to do my x divided by y. So I'm going to do 1/2 divided by negative root 3 over 2. Again, we have done this enough times that I already know what my answer is going to be. If you don't, that's okay. We multiply by the reciprocal, which gets my 2's to cancel out. And then I have to rationalize so that I don't have a radical in the denominator. And I get negative root 3 over 3. Again, I don't even think you need to show this out. If you have done this enough times and you just remember once you write it like this, that it's going to end here, that's totally okay with me. You can. You only have a certain amount of time. So, and make sure that you know some or can at least get there a little quicker. I'm going to tell you, I don't even care what this is as a degree. I just know that it goes with 60. I don't need you to necessarily know this is 300, but instead I know all my pi over 3s are 60-degree angles. All my pi over 6s are what kind of angles? 30-degree angles. And then all my pi over 4s are what? Those are 45s. So that is enough that like, I don't even care what that angle is, but I know it's special because I'm being asked it. I know that it's a 60-degree angle. Questions on this one? I think I saw a hand. Did I ignore it? Yeah.
There are, so I don't know if you're going to be able to have like.
I'll give you a blank one. Avery asked, can I have a blank unit circle? Yes. Nikki. I'm probably going to be like a 25-minute or 30-minute quiz, which is what the last one was. Okay, should I go to the secant one? Secant is what in terms of x and y, or which function is it the reciprocal of? Cosine, so that means it's going to be 1 over x. Now, 3 pi over 2 is one of your quadrant angles. That's 270, and I know it goes 0, -1. So it's going to be 1 over 0. What is 1 over 0? Undefined. Is that an okay answer?
Yep.
Yes. And then last one, cosecant. What is that in terms of x and y? Sine, so it's 1 over y. And 7 pi over 4, is that a 30, 45, or 60-degree angle? 45? I know that that point goes √2 over 2, comma √2 over 2. What about, what quadrant would 7 pi over 4 be in? 4, very good. So that means my y is negative. So I'm going to do 1 over y, which is 1 over -√2 over 2. Again, we've done this enough. You might know where it's going to go because I have to multiply by the reciprocal. I have to rationalize the denominator. I have to simplify. And I end up just getting a -√2. You don't necessarily have to show me out this much work if you've done enough of these. And if you've really practiced these, you probably have done enough that as soon as you get 1 over that, you're like, oh, I know I'm going to end up in √2. So you don't necessarily have to show me that work. You don't really have to show any work, but I will tell you that if you get it wrong and you show me a little bit of work and I'm like, oh, they were right there, but they picked y instead of x, or they switched this. If you show me a little bit, maybe I can find some extra points. Yeah. Yeah. And then, yeah, and you can even do that. We know that all students take calculus is a thing as well. And so I can even like wait till the very end and be like, okay, I know cosecant is sine, and in my fourth quadrant, sine is negative, and I can just add that negative at the very, very end. Okay. If you look at that homework I just passed back to you, everything on there is fair game except for number 4. That's probably good for some of you, because some of you, I don't know what you were doing on number 4 / you didn't do anything for me on number 4. 1, 2, 3 are all fair game on the quiz. Definitely number 1. Some of you really struggled with number 1, so make sure you figure out number 1 before quiz time. Yep, John.
If we do it wrong, we not got to check.
I would have circled something, or I would have like drawn arrows or something. I think you did something that a bunch of people did. You switched your opposite and adjacent. And so that's why I like put like arrows to
Yeah,
kind of look up.
let's see.
Yeah, or some of you did a great job and then you lost your negative, so I wrote a negative in front and put a circle around it. Okay. What's the one other thing besides what we just practiced and what's on your homework? What's one other thing that you need to know for this quiz? Word columns from 4.2. Yeah. So if you have 4.2, it's just a front side. Just a front side. And I'll have the unit circle will be a separate sheet of paper. So if you need to look at that, it will just be completely separate. Right. I've got some homeworks and some quizzes. I'll find some time to pass those out in a minute. But what we're going to do now is we're going to move into graphing. So if you can put everything but your notes aside, you can keep your unit circle out. We're going to reference it for a second. And you don't really need a calculator today, I don't think. Finish what? We should have finished 4-3.
4-4.
No, we're not going to finish 4-4. We're gonna get very barely started on 4-4 to be quite honest. So the only homework you'll have is to study for the quiz. I accidentally did the practice on that thing, that's my bad.
So up here, it already said this way. Do you get a calculator?
Yes,
We didn't.
because when you do the word problems, you have to have a calculator. Go ahead, get those notes out. So, as we're looking at our notes, we are graphing today. Graphing is hard. I'm not gonna sugarcoat it. Graphing's a little hard, but we're gonna try to take it just a small bite size today, okay? We are worrying about these sine and cosine graphs. And if you guys remember, we did graphs of sine and cosine as your BFF graphs. Do you remember what I told you you had to know about sine and cosine graphs when we did our BFF test a long time ago?
They go in between one and negative.
They go in between 1 and -1. What did you say, Adrian?
Like the placement.
Yeah, do you remember what that placement was?
Whether it was on 1 or 0.
Ooh, which one was on 1 and which one was on 0?
Sine was 0.
Sine was 0. Bless you.
And cosine was 1.
Cosine was 1. Very good. So we're going to start by actually going to letter 1A and B. We're going to sketch those graphs first. Okay. So sine. Joey told me that we couldn't go any higher than negative or than +1. Couldn't go any lower than -1. Avery told me we started at 0, correct? Do you guys have your unit circle next to you? Okay. Do you remember sine? Is that your X or your Y value? Y. Sine's your Y. Okay. I only am going to care about the quadrant angles right now. So we are going to graph where sine is at 0, at pi/2, at pi, at 3 pi/2, and at 2 pi. Do you notice that when you look at your unit circle, the y or the sine at 0 is 0? That's kind of cool that we already knew that. What's your sine at pi/2? +1, right? Can you go graph a point at pi/2, 1? What's your sine at pi? Nope. Remember, sine is y.
0.
0. What's your sine or your y value at 3 pi/2? -1. And what's your sine or your y at 2 pi? 0. I got it, Mike. 0.
That's cool.
And then it's going to be kind of wavy. Okay, so it's going to be wavy. We've got those 5 lines or 5 points right there. And we're just going to wave this line through it. Wave up, wave down. Make it nice and curvy. Make it wavy. Okay. How did I figure what out? Those points?
That they're 1 and 0 and -1.
Look at your unit circle. What are your y values at all of those points, right? So at pi/2, your y was 1. That's your sine value.
Oh, okay.
Yep. Okay. This, right now, we've got 2 qualities of our graph. I've got something called amplitude and I've got something called period. The amplitude deals with my vertical distance, okay? Your amplitude is if I'm starting at the middle of my graph, how far up and how far down do we go? What's my amplitude here? How far high and how far low am I going?
1 and
1 and -1. Let's think of it as a distance, and distance is always positive, so my amplitude is always just 1. I'm going as high up as 1 unit, I'm going as low down as 1 unit below from where my middle was. Okay?
Could it ever be like, go up on the,
Nope. John asked a really good question. Can we go up farther than we go down, or can we go down farther than we go up? Nope, it's always going to be equidistant on top and on bottom. Okay. Now the period is what we call our horizontal length, essentially. So I'm going from 0 to 2 pi. So it takes me 2 pi units to do my whole cycle. Sine and cosine are wavy. A better way of saying it is they're cyclical. They start somewhere, they do their full cycle, and then once I reach that starting point again, I'm going to cycle all over again. So I have one period drawn here. I could have gone backwards and drawn another period. Bless you. It's a full circle, which is 2 pi. That's 360 degrees, but we're going to measure in radians. So it took us one full rotation of the circle to get all those points. I could have gone backwards. If I would have gone backwards, I would have had to go low and then middle and then high and then middle again. See, when I connect these dots, it's the same wave pattern as I had before. Wave up and then down, and then wave up and then down. We're only going to practice just graphing one period at a time, but technically this goes on forever and forever and forever. Okay. Let's do our cosine graph while we're thinking about it. We said sine was our y value on our unit circle. What's our cosine going to be? Our x value. And you guys had already told me that we can only go as high as 1 and as low as -1. And where does cosine start again? At 1. It starts up at 1. We're going to do one whole cycle again. We're going to do one whole period, and that's our whole circle. So we're going to go from 0 to pi over 2, to normal pi, to 3 pi over 2, and then to 2 pi. Now, when you look at your unit circle, is your cosine or your x value for 0? 0? Or sorry, is it 1, like we said it was? Is your x value at 0, 1? Yep, and so the x is just 1. Yeah. Now go to 90, go to pi over 2. What's your x value there? 0. So I'm going to graph at 0. And at pi, it's -1. And then it's 0. And then at 2 pi, it's 1. Is everybody okay with how I'm getting these numbers? These are all the x values at those angles.
Yep.
After this, you don't have to use your unit circle again. You'll just know the pattern of these points. And this, again, is wavy as well. I know it's going to be a little bit tougher, but try and make it look wavy. This kind of looks like the Colts horseshoe. Doesn't it kind of look like a horseshoe? A little bit.
Do we have to,
Be generous.
we have to write the pi over 2 to?
We do have to write that. Yeah, John asked a really good question. Do I have to label my graph? The answer is going to be yes, and you're going to see more that we do why we do that, okay? Now, again, I could go backwards in the same way. I would have had to go to 0, and then I would go down to -1, and then 0, and then back up at 1. And again, this still is my wavy pattern. It's curvy, it's wavy, and it's still waving right through 1, 0, 1, which we knew is where it's starting. Yes.
So are you just gonna have us graph it based on different numbers?
So yeah, so now we're going to talk about changing the equation. Okay, when we have normal cosine and normal sine, my amplitude is always 1, my period is always 2. Today, we are going to focus only on changing your amplitude, so your vertical, and your period, your horizontal. We're not moving anything left and right. We're not moving anything up and down. We're just stretching and shrinking vertically and horizontally today. Okay, so that means if I come up here, we only care about my amplitude, which are these A's. And again, amplitude is my vertical stretch and shrink. Your amplitude is literally just your A value. So if I go, hey, look at this equation, what's your amplitude? It's whatever number is in the very front of your equation. And when we did transformations back in chapter 1, we talked a lot about doing y times a. So whatever the amplitude was, you multiplied all your y values there. You can think of that the same way here. I don't necessarily do that, but if that helps your brain, I wanted to write it down. The other thing I care about is the period, and that's your b value. It doesn't matter if it's inside or outside the parentheses. We'll talk more about the parentheses next class. The b helps you determine your period. The b is not your period. By definition, the period of a function is the horizontal length. And normally your horizontal length is 2 pi, going all the way around the circle. If your period is changed, that letter B will be divided by 2 pi to tell me what my new period is. Okay. If there's not a number in front of x, then it's just 2 pi. If there is a number in front of x, we're going to do 2 pi divided by that number. Okay. So let's go look at a couple examples of this. Can I keep it moving? Okay. Let's look at letter C. That 2 right there, is that an amplitude or a period? Amplitude. That changes my amplitude. So instead of saying my amplitude is 1 like we did earlier, my amplitude here is 2. It matches whatever your A, whatever your number up front is. My period, though, is there a number in front of x that's going to affect my period? No, so what's my normal period again? 2 pi. I teach this a little bit differently every year, but I really like kind of making a boundary for my graph, so I'm going to start there. I'm going to do my amplitude. I can go as high as 2. I can go as low as 2. I'm not shifting up or down any. I'm not shifting left or right any. So I'm staying at positive 2, negative 2. And I'm going from 0 and I'm ending at 2 pi. We get to use our normal angle since my period is normal. So I'm going to do 0 to 2 pi. And then I can just do the angles we're used to, our normal quadrant angles. Pi over 2, pi, 3 pi over 2, 2 pi. Yeah, John?
You would never go over 3, or is that just like this?
That's just what these graphs are. Now, and I like to do a little grid. So you have a nice grid here. So if you don't want to draw on your graph, that's fine. But sometimes I draw like a little dotted line to tell me, okay, you have to go as far left as this. You have to go as high as this. You have to go as far down as this. The biggest problem you guys do is you'll label it perfectly, but then your sign will be like here. And it's like, that's not fitting your whole box. Your sign has to fit the entire box. That's why this grid is here. Okay. And so we are doing our sine function. Can you remind me where does sine start? Does it start at the highest point, the middle point, or the lowest point? Middle point, good, at 0. And then do I go up or do I go down? Up, good. Then my next point is, next point's in the middle. Then I go down. And then finally I end back in the middle. I have to make sure my sine takes me all the way from 0 to 2 pi evenly. I have to make sure it goes as high as 2 and as low as negative 2. And then once my dots are there, I just connect my lines. I draw my little graph. The directions say you only have to sketch one period. So I've sketched that one period right here. You could keep it going, but all I need to see is this. Yes.
Will we always be doing from 0 to 2 pi, or?
Nope. Hold your horses.
And then if it doesn't touch the highest point and lowest point, you get it wrong.
I'd probably like draw a little arrow and be like, it's got to go higher than that. Charlie.
But you just find one side period.
One period.
Reflect it over.
Yeah, and you could take it over here. You could go all the way down, all the way up, but you don't have to.
That's only.
Sometimes that's 2 periods.
I will never ask for 2 periods. I will only ask for 1. Good question. Avery, questions?
So then what if there's 2?
Ooh, should we do another problem? Okay, we're gonna do 2 more on this paper, and then I've got some I'm gonna put on the board that we're gonna try, okay? So let's do letter D next. Okay.
On the other side.
Say one more time.
Put the period on the other side.
I love that you know that it's gonna flip. It's not gonna flip it this way. It's gonna flip it up and down. Okay, so John recognized that I've got a negative 3 out front. That's going to affect my amplitude. My amplitude is 3, but that negative means that I'm going to flip my cosine. Instead of starting at the highest point, it's now going to flip and start at the lowest point. Do I have a number that changes my period? No, so what's my period then? 2 pi, good. We're going to set our graph up. I get to go as high as 3 and as low as negative 3. And then again, I'm going to go from 0 to 2 pi. I have not changed my period, so I'm going to keep using the same angles that we've used. 0, pi over 2, pi, 3 pi over 2. And again, if you like making a little border, make a little border. Everyone okay with your graph labeling? Now we're ready to do our cosine. Does cosine usually start high, medium, or low? My usual cosine graph normally starts high, medium, or low. High, but just like we mentioned, we had to flip it. So I'm going to go low. I'm going to start at my lowest point. Then I'm going to hit the middle. Then normally I go lowest, but I have to flip it. So I'm going to go highest. Then I'm going to go back through the middle and I'm going to end on my lowest. Now this kind of looks like an upside down horseshoe. Kind of like a weird parabola that's curvy at the ends. You guys okay with this so far? Okay, let's do one more. Now I'm going to change both my amplitude and my period, okay? What's my amplitude going to be here? Good. What's my period going to be here? I wish it was just 2. I'm going to do 2 pi divided by that number. 2 pi divided by 2, which makes it just pi. And for sake of demonstrating, I'm going to keep the scale the same that we have. I'm going to go as high as 2, as low as -2. But since my period now is pi, I have to squeeze my sign. Now it can't take 2 pi to finish my sign. I got to finish my sign in pi units.
So you normally would move it down the line.
Yes, and I'm going to do a little different graph on the board in a second. And when we draw our own graph, you can label your graph however you want. So they're all going to look the same, even though they're going to have different numbers. This one, I want to show you it shrunk a little bit, okay? That means that my last point is no longer 2 pi, it's pi. I divided it by 2 to get that. That means in order to find all my other little points, I'm going to take the points that I normally do and I'm going to divide them by 2. I'm going to take all my points and divide them by that b value. Okay, so my first point, 0. 0 divided by 2 is just 0. My other next one is pi over 2 divided by 2. Well, pi over 2 divided by 2 is the same thing as pi over 2 times 1/2. What's that going to be? Pi over 4. Good. Which makes sense because I'm doing half of a half. Half of a half is now down to a 4. My next angle is just pi, and I'm going to divide that by 2. Oh, I can just leave that as pi over 2, right? And then my next one is 3 pi over 2 divided by a half, or sorry, divided by 2 or times a half. 3 pi over 4.
These are in like half of the boxes.
Yes.
But when we do it, it's gonna be big.
Yeah, we'll do a bit bigger in a second, but when it's on a grid like this, I'm showing you how, like, what the period is actually doing. See how it's going to be really scrunched up? Yeah, that's going to be okay. And so now I've got my grid. I have to go as high as 2, I have to go as low as -2, and I have to be done by pi. And I have all these marks done so that I know where my important points are, okay? My sign is still a normal sign. Am I starting high, middle, or low? Middle. And then where's my next point going to be? High. And that's between 0 and pi over 2. It's at pi over 4. It's halfway between the grid mark. Then at pi over 2, at the actual grid mark, I'm going to be back at 0. And then halfway between the grid marks at 3 pi over 2, I'm going to be at my lowest point. And then I'm going to jump up and be at the middle point again. If you compare this to letter C, it's almost the same problem, but do you see how it's scrunched? That's what the period change does to it. It makes it smaller horizontally. Okay. Instead of us moving on and doing some other transitions, we're going to really focus on these these period and amplitude changes. I've got 4 problems that I'm going to write on the board. If you have blank paper from earlier, or if you just have blank paper that you want to write on right now, we're going to do 4 other problems that are like this, okay? Okay. First one we're going to do y equals 2 cosine 1/2 x. Y equals -4 sine x. Y equals 1/2 cos 2x. Y equals 2/3 sine 3x. I just made these up. So these are just kind of random problems that I was like, these are hard enough, similar to what we were doing, that we can practice them. I actually like doing it like this better than what we did with the actual like grid on our paper, because now I can make this grid however I want it. And I like to just do kind of like a T-chart like that, basically. I usually just make my period that I want to show just like that first positive one that I can.
So
John?
the period will never go the opposite way.
Sometimes if we do like a horizontal, like left and right movement, you might go a little bit over here, but generally I start at 0 because that's the easiest point to start at, right? Okay, what changes do I have here? Any amplitude change? 2. Good. My amplitude is going to be 2. So that means I go as high as 2, as low as -2. And this is your graph at your scale. You can put 2 wherever you want. I just usually put it at the top and at the bottom. Now my period, my B here is 1/2. So that makes my period, good, 2 pi divided by 1/2. And 2 pi divided by 1/2 is like 2 pi times 2. So my period now is 4 pi. That means I have all the way until 4 pi to get my sign done. And when I have a graph like this, I just go to the end of my line and I write 4 pi down there. Okay. The angles that we have been using this whole time, 0, pi over 2, pi, 3 pi over 2, 2 pi. Just like we took that last number 2 pi and divided by 1/2 or times it by 2 to get my period, I'm going to take all of these numbers and multiply it by 2 to get their points. So 0 times 2, 0. What about pi over 2 times 2? Pi. What about pi times 2? 2 pi. What about 3 pi times 2 over 2? 3 pi. And then just like we did a minute ago, 2 pi times 2 is 4 pi, which is where we wanted to end anyway. Now, if you like your little grid, and especially on these, I really like it, but you can do what you want. If it doesn't make you happy, don't do it. And now I want to draw my cosine graph. Where does cosine start? High, medium, low. High. Then we go medium, then we go low, we go medium, then we go high. Yeah. That's how the unit circle goes. So at a certain point, I just know those 5 points. It starts high, you go all the way to the bottom, you bounce. Do you think you can try number 2 on your own? So you can pass out a couple more of these papers. Try number 2 on your own. Yeah. Never mind. Why don't you hold on to that so you can use it to study, and then I will create it. All of those. All the things that I corrected it already. Take a second. I will join you guys momentarily. Try number 2. If you get done with that one, try number 3.
You have to put pi, 2 pi. One.
So the general angles are those on the board. 0, pi over 2, normal pi, 3 pi over 2, and 2 pi. So those are the ones I always do, and I change them based on what the period is. Another question?
Yes.
Did that answer your question?
graph.
The graph is what I'm looking at. And I'm looking at to make sure you have the right sine or cosine curve. So even if you screw everything up, but you're like, that is a cosine curve, I'll give you credit for that. Yeah, right now, when we're not moving left or right, yes.
And how did you change the point of the, like, you need to do that?
Do what? For time?
Change the, I don't know. Fives.
I got these.
Yeah.
I knew that I multiplied 2 pi by 2 to get my new period. So I multiplied all of these angles by 2. So whatever your B is, that's what you're gonna do to get all of these. All right, I'm gonna start talking. Yep, you may. I'm gonna start talking through number 2. If you're like, I got that, let me try a harder one, then keep going. If you're like, I'm just gonna ride along on the wave, go for that. All right, first thing, amplitude and period. Amplitude on this number 2 is 4. 4 amplitude's a distance. That negative makes it do what though? Flip. Good. What's my period going to be here? 2 pi. Good. So that's actually easy. We don't even have to do anything crazy with our angles. I'm just going to set my graph up. I'm going to go as high as 4, as low as -4. I don't have to change a single angle. I just use the normal ones. 0 pi over 2 pi, 3 pi over 2. Grid. And it's sine, but it's flipped. So where does sine start? 0. And then because I'm flipping it, am I going to go up first or am I going to go down first?
Yeah.
Down, because normally I go up, so we're going to flip it. We're going to go down, and then back to the middle, and then up, and then back to the middle. So the shape of the curve is something that I'm looking at. You get points for that. And then you labeling your amplitude and all your angles to show your period. You also get points for that. Carson.
When did you start at 0 or
Whatever the amplitude is. Sine always starts in the middle. Sine always starts at 0. Cosine always starts at one of the end points. And if it's normal cosine, it starts up high. If it's a negative cosine, it would start low. That's why on your notes, we have a negative cosine that starts low. And then I did a positive one over here that goes high. Avery.
Do the like, sand, like the river.
Oh, secant. Ooh, yes, that's 4.5.
Yikes.
That sounds even more.
Okay, let's do these last 2. Remember, I'm not giving you homework. Your only homework is to study, so I'm going to grind these last 2 out. What's my amplitude going to be here? Good. What's my period going to be here? 2 pi over 2, which is just pi. That's all right. We were thinking through it. I like that. Just pi. Okay, and again, I'm making my graph, so I can make it look however I want. I'm going to say wherever it ends is just where pi is. And I'm going to say whatever the highest point is 1/2. I'm going to say the lowest point is -1/2. That's why you label it. So I know, okay, this is 1/2. Does it look the same as 4 did a minute ago? Sure, I don't care. Just label it. Okay, now we got to do our angles. We just divided 2 pi by 2 to get pi as my new period. I'm going to take all of these and divide them by what? 2. 0 divided by 2 is 0. Pi over 2 divided by 2. Pi over 4. Pi divided by 2. Pi over 2. 3 pi over 2 divided by 2. 3 pi over 4. Good. See, the more we do it, the less hard it is, right? Good. Definitely gave them 8s last time. I don't know how this happened. That's okay. All right, draw your little grid. And then this one's cosine. Does cosine start high, medium, low? High. Middle, low, middle, high. Okay. It looks like we're going to run out for this last one. Can you tell me what my amplitude here would be, though? 2/3. That's not that scary because you can just label it 2/3. Am I right? What's my period going to be here?
5. 2 pi divided.
2 pi divided by 3. And how would I find all my angles in this one? What would I divide all of my angles by? 3. Is that going to get kind of gross? Yeah, but can we do that? Absolutely. We might start with that next class just so I can show you that you can do weird and hard things, okay?
Would it be like the pi?
Yeah, pi over 6. All right.